Guys, today we're going to be doing multiplying radicals, and this is just kind of a continuation on with yesterday's lesson. So you're going to get kind of more examples from what we did yesterday, only this time we're going to be adding the multiplication of two radicals into it. I don't think you're going to find this too difficult. For example, number 1, I have radical 2 times radical 3, or the square root of 2 times the square root of 3. Notice there's no little number there. So that just becomes, I can't do anything with the square root of 2. I can't do anything with the square root of 3. So you just multiply the numbers together, and radical 6 is the answer. Okay? So all I did was multiply the 2 and the 3. Now here, I can't do anything with 2, and I can't do anything with 5. I have a 3 and the 4 on the outside. So I just multiply the outsides, and I multiply the insides. I get 12 radical 10. That cannot be further simplified. If you notice, I multiplied those two, and I multiplied those two, keeping those two underneath the radical. Over here, now, there's two ways I can do this. I can multiply these two numbers, get radical 48, and then go ahead and take the square root. Or I can simplify each one of these first, and then go ahead and take the square roots. I like to simplify first, so I'm going to take the square root of 12. Hi, Emily and Adam. You're watching this. The square root of 12 is the square root of 4 times the square root of 3. The square root of 4 just becomes 2. So now I have the square root of 4. That pops out as a 2. So now I have 2 radical 3 times 2. And then you just multiply the outside numbers. I get 4 radical 3 as my answer. Had I done it like this and did 48, then I would have gotten 16 times 3. The 16 would have popped out as a 4. I would have gotten the same answer, 4 radical 3. Got it? All right, now let's look at this. We have the cubed root. Don't look at this part yet. We have the cubed root of 1125 times the cubed root of 63. You have to do 1125 and go ahead and do your little ladder thing. When you're done with 1125, you should come out with 3 squared times 5 cubed. I didn't want to take the time to do all that. The cubed root of 63, you're going to do the same thing, is 3 cubed times 7, because it's 9 times 7, which is 3 squared, I'm sorry. So now, when you multiply these, you're going to keep the cube. 3 squared times 3 squared. When you're multiplying two bases with two exponents, what do? You add the exponents. 3 squared times 3 squared is 3 to the 4th times 5 cubed times 7. Okay, but now I've got to pop out anything that has a cube. All right, so here we go. We're going to do the cubed root of, what is 3 to the 4th? It's 3 to the 3rd times 3 to the 1, 5 to the 3rd times 7. Now that can all pop out. The 3 pops out. The 5 pops out. 3 times 5 is 15. Cubed roots of whatever's left inside. That popped out and that popped out. So I've got a 7 times 3 is 21. That's the answer. 15 cubed roots of 21. That one's a little complicated. You might have to look up that one over again. That's number example 4 in your book. You might want to relook at that one. Now this one, now we're talking with variables, okay? So we have 2 square roots. We're multiplying square roots together. We're going to multiply the 6 and the 2 to get 12. Multiply the A, the B, and the C. So I'm going to get A, B squared, C. Now there's no number written here, so we know that's a 2 understood. Now I have to take the square root of 12, AB squared. The B is going to pop out as a B. The 12 becomes 2 squared times 3. And then we've got AB squared C. So the B pops out, the 2 pops out, and my final answer is going to be 2B times square root of 3A. Okay? C. Ooh, I forgot the C. There's a C in there too. All right? So that's that one. I'm going to put a little square root over that so we don't get confused. Now, last one. Always get your numbers down to their bases. You have a cubed root here. So you should know by now that 4 is 2 squared. Then you've got x squared, y to the 5th, z. I'm just going to keep this all under 1 square root. I'm just going to go ahead and turn that into 2 cubed. Hopefully you know that that's 2 cubed now. And then x cubed. So I've got 2 squared, x squared, y to the 5th, z times z, 2 cubed, x cubed. This is where I think you had a little issue yesterday when you have variables with a cubed root. Anything that's 3 or bigger, you can pop out. The 2 pops out. The x pops out, but I still have some stuff over here. So I'm just going to rewrite this without the 2 and the x. 2x cubed roots of 2 squared, x squared, y to the 5th, and z. I am not done yet. Which one here does not belong inside the cubed root here? Does anybody know in the class? Anybody know which one doesn't belong in here? That has to pop out. You guys probably haven't done this yet? No. Emily, which one of these numbers, this is a cubed root, which one of these variables does not belong in here? Which one can pop out? It's a cubed root. Can the 2 pop out? Can the x pop out?
Why?
The y. The y can pop out. Why? Because 3 is smaller than this exponent. 3 goes into 5 one time, so y to the 1st is going to pop out. 2xy, cubed roots. Now what's left over? If 3 goes into 5 once, there are 2 left over. So I'm going to just go ahead and multiply that back. 4x squared y to the 2nd z. Okay? If you guys need, that's the final answer. If you guys need more help,